Good afternoon, students, all of you. The last class we started solubility of solid in liquid, no? So in the solubility of solid in liquid, we discussed factors. What are the factors? Nature of solute, nature of solvent, effect of temperature, effect of pressure we discussed. So once see this, this is PPT I am sharing for you. Solubility of solid and the dissolution and crystallization and how temperature will have effect on solubility. Pressure has no effect. Why we discussed yesterday, since solids are incompressible. Whereas effect of temperature, the solubility may either increase or decrease with increase in temperature. It depends on enthalpy of solution. That means it may be either exothermic or endothermic. If it is exothermic, solubility decreases with increase in temperature. If it is endothermic, solubility increases with increase in temperature, that we discussed. See, that is what effect of temperature and pressure on solids. And see this, can you give answer? If we increase the temperature, then what will be the effect of solubility of solid in liquid? Some NCERT question. If you increase the temperature, what will be the effect of solubility of solid in liquid? As we discussed yesterday, it can be either exo or endo. No, if it is exothermic, with increase in temperature, solubility decreases. If it is endothermic reaction, solubility increases with increase in temperature. So here your answer should be depends on enthalpy of solution. It depends on enthalpy of a solution. Understood? If it is exothermic, solubility what happens? Decreases with increase in temperature. If enthalpy of solution is to be endothermic, what is endothermic? Heat is absorbed. Then solubility increases with increase in temperature. This we discussed yesterday. Recollect. Conceptual question we discussed yesterday. Now see, this is what in PPT they are showing solubility of gas in liquid. I think so. Yesterday we are in solubility of gas in liquid. This is what effect of pressure on solubility of gas. This I will explain you once again on the board. Later I will share the PPT. Okay, students. Now today our discussion will be how what are the factors that influence the solubility of gas in liquid. So write heading effect of solubility of gas in liquid. In this yesterday I taught you nature of solute, nature of solvent, that I am not going into that, already we completed. And effect of temperature also I completed, and I told you in effect of temperature, solubility of gas in liquid is exothermic. So with increase in temperature what happens? Solubility of gas decreases because enthalpy of solution is exothermic. That we completed. Now I have to teach you effect of pressure. See, the third factor, getting idea all of you students, effect of pressure. This is very important. In JEE means as well as in NEET we get questions from effect of pressure. Now very simple it is, see what is this effect of pressure. I taught you that yesterday Henry, the name of the scientist, what is the name of the scientist? Henry. So Henry, what he said, he has given one relation. That's what in daily life we see is aerated drink. If you observe soda bottle, when you open the soda bottle, what you observe? Some hissing sound, gas will come out. Might be you experienced in your daily life. So why? Because see what Henry said, the mass of the gas dissolved in unit mass of solvent is directly proportional to pressure of the gas, he said. Partial pressure of the gas, yesterday we wrote this relation, where M is mass of the gas, P is what? Partial pressure. Keeping what constant? Temperature constant. So what is the statement given by Henry? Mass of gas dissolved in solvent at a given temperature, keeping temperature constant. Mass of gas dissolved in a solvent at constant temperature is directly proportional to partial pressure of the gas, he said. Directly proportional to partial pressure of the gas, he said. Who? Henry. and mathematically we represent m proportional to p. This is important, where m is mass, p is what? Partial pressure. This you understood, all of you. Yesterday already we discussed this. Once again I am continuing for your understanding. So this is mathematical relation m proportional to p. Clear, students? Do you all copied this, right? Now see, next, coming to next, in his own student called Dalton. Yesterday we discussed Dalton. So Dalton, what he considered, the solubility is taken in terms of mole fraction. Who? Dalton. Solubility is taken in terms of mole fraction. See, according to Dalton, the solubility is a measure of mole fraction he considered. Solubility is a measure of what? Mole fraction. That is chi. You remember the mole fraction is shown with the symbol what? Chi. And what he said, the mole fraction in terms of solubility is directly proportional to partial pressure, he says. Understood, student? The solubility which is taken in terms of the solubility is taken in terms of mole fraction, which we are representing with chi, is directly proportional to what? Partial pressure, he said. So Dalton. And removing this proportionality, we multiplied with a constant. See, x is equal to, already as we wrote k, now I am writing k prime. See, k prime into p, where k prime is a constant. Now from this I bring this relation partial pressure. Now see, student, partial pressure is equal to, what should I write? This k prime comes to left side, no? Then what I write? X upon k prime, and this reciprocal of 1 by k prime is called Henry constant. So this, now onwards we represent reciprocal of 1 by k prime is what? Kh. What is Kh here? So finally we write another statement, C. Partial pressure of the gas is equal to Kh into chi. Now what is Kh here? This is important relation. In exam you get questions on this. Where P is partial pressure. What is P, student, here? P is the partial pressure. And what is Kh here? Kh is Henry constant. To honor whom? Henry. In the name of that they called Henry constant. This is called Henry constant. And what is chi? Chi is mole fraction. This chi, what we are calling as a mole fraction. So this is the second statement we can write. That means the partial pressure of the gas is directly proportional to mole fraction of the gas, where P is partial pressure, Kh is Henry constant, and X is what? Mole fraction. This is the second statement from Henry law. So what is the statement we can give from that relation? So see, statement 2 I am writing here. The partial pressure of the gas, that is partial pressure of the gas, partial pressure of gas is directly proportional to, partial pressure of the gas is directly proportional to mole fraction of the gas. Directly proportional to mole fraction of the gas. Mole fraction is shown with the symbol what? Chi. This is the second statement given from Henry's law. And this is a very important relation. We get numericals on this both in JEE NEET, JEE as well as in NEET exam. So partial P is partial pressure, Kh is Henry constant, X is mole fraction. Copy this up to this. Clear up here, all of you? Simple. So this is what Henry's law. That means how pressure will have influence on the solubility of gas in a liquid. Clear, students, all of you? This is very, very important in JEE mains as well as in NEET. They are asking questions from Henry's law. Copied, all of you? These two relations, two statements we got. First statement is what? Mass of the gas is directly proportional to partial pressure of the gas. The second statement is what? The partial pressure of the gas is directly proportional to mole fraction of the gas. Copied them, all of you? Is it clear for all? Simple, no? Now see. Now let us see right heading, units of KH. Now what is KH, students? See, here I am writing in the next page. Copied all of you this one? Clear, no? Right. See, next page I am going, in the next page, see, What is that relation we wrote? P is equal to, what is P, student, here? Partial pressure. This partial pressure is equal to Henry constant into chi we wrote, no? So it is in the form of y is equal to mx plus c form. Straight line equation, no? So it is in the form of y is equal to mx plus c. Now see, in this relation intercept is 0, no? So here c is the intercept, x is the slope. Getting idea, all of you? Now when we plot the graph between what versus what, on the y-axis I am taking partial pressure. See, on the y-axis partial pressure, and on the x-axis I am taking mole fraction. Understood? Partial pressure is taken on the y-axis and mole fraction is taken on the x-axis. So here intercept is 0. So what type of graph do we get? See, here we get a straight line passing through origin. See, the graph will be straight line passing through origin. And what is the slope here? See, m is the slope. And what is the slope in exam they ask? The slope will be equal to what? Kh. What is Kh? Henry constant. So in exam graphical approach also they ask, what type of graph do we get? See, straight line passing through origin, and this is slope. What is slope here? Slope will be equal to Kh. Understood, all of you students? So this is important. In graphical approach also they ask, what type of graph do we get when we plot partial pressure versus mole fraction. Clear for all? Now see what units this Kh will have. Units of Kh. See, units of Kh will be pressure unit. You know, pressure is measured in what? Bar, or we measure in atmosphere. So in the numerical, they give the unit of Kh as what? Unit will be bar, it may be, or it may be what? Atmosphere, it may be. And you have to know the conversion. One sometimes in problem they give in atmosphere, the other will be asked in bar. Or you know, pressure is also measured in what? Pascal. So 1 atmosphere is equal to 76 centimeter of Hg. What is Hg? Mercury level. That is equal to 760 mm of Hg. Because in numericals they may give the pressure in bar, or in option they may ask in atmosphere. This you get conversion factor in states of matter. And this is equal to 1.01325 into 10 power 5 pascals. You know, the SI unit of pressure is what? Pascal we say, or Newton per meter square. So this conversion you have to remember, copy this relation. And what will be the unit of Kh if they ask? Unit of Kh will be same as the units of what? Pressure. It can be atmosphere or it can be bar. Are you following, students, all of you? See, this is what a graphical approach, and these are the units of Kh. And conversion factor you have to know. In numericals they will ask you conversions from one unit to another unit. That's what you studied in first year, some basic concepts of chemistry. Unit conversion factor. Clear? Shall I move to next? Right. Copied all of you, right? Now see next one. See, next we have to study what is the effect of temperature on Kh. So next our discussion is how temperature will have influence on Kh. Now observe here, student, all of you, important. So in NCERT they are expressing, and even in exam they ask you what will be the effect of temperature on Kh. Effect of temperature on Kh. Now see, as temperature increases, the Kh value also increases. That means Kh, how it is related with temperature? Directly proportional. So here make a note, as temperature increases, with increase in temperature, what is Kh, student? Henry constant. Kh increases. So tell me, when temperature is increasing, Kh value is increasing, no? So what happens to solubility of the gas? What is the relation we wrote? Partial pressure is equal to Kh into X we wrote, no, student? So with increase in Kh value, what happens to solubility? See, as temperature we are increasing, Kh value is increasing, solubility of the gas, what happens? Decreases. So in exam, how they ask, they give you Kh values, arrange them in the increasing order of their solubility they are asking. So can I say here, as temperature increases, what happens to Kh value? Kh value increases. So solubility of the gas, what happens with increase in Kh? Solubility of the gas decreases. That's what, if you remember, aquatic life like what? Tadpole, fishes, they can survive at what condition? High temperature or low temperature? When the temperature is low, what happens? Solubility of the gas will be more, they can survive, no? So with increase in temperature, what is happening? KH value increases. So solubility of the gas, what happens? Decreases. So this relation is important. Copy this relation. In exam conceptual they ask, what happens to KH when with increase in temperature? So as temperature increases, KH value increases, solubility of the gas decreases. And in exam they ask you like this, suppose I am taking 3 gases or 4 gases, A, B, C, D gases they give you. Their values will be mentioned. Suppose the KH value for A is, let us assume 2, and KH for this is 3, and KH for this is 4, and KH for this is 5. For example, I am assuming these are the values for the 5 gases. Now in exam they ask you arrange them in the increasing order of their solubility. Can you guess? I want from lower solubility to higher solubility. Now tell me how will be the solubility as KH value is lower, lower is the KH value, higher is the solubility. Do you agree? Because KH is inversely proportional to what? KH is inversely proportional to solubility. With increase in KH, what happens? Solubility decreases. So I want from lowest to highest. Who comes the lowest among A, B, C, D? The value that is having highest. So D comes to be less. Then comes what? C. Then comes what? B. And A is having higher solubility. So this has been asked in exam point of view. So they can give the values of KH to you and they ask you arrange in increasing order. Conceptual question they can ask from this KH value. Or in assertion reasoning, they can give assertion with increase in temperature, KH value increases. And in statement, they give you as temperature increases, solubility of the gas decreases. Are you following, students? Everyone, is it clear? This is what very important, the effect of temperature on KH value. Copied everyone? Clear, all of you? This relation is important. And done. So with this effect of pressure towards solubility of gas in terms of Henry's law completed. Now let us see what are the applications of Henry's law. So next our discussion will be what? In NCERT we are having applications of Henry's law, right? Heading applications of Henry's law. Shall I move to next page? See, completed all of it, right? Now see, I am moving for next page, right? Heading applications of Henry's law. Now see, in NCERT there are few applications of Henry's, very important in exam point of view. They are asking questions on conceptual base. So there are 3 applications mentioned in NCERT. What are the 3 applications? See, one is aerated drink. Might be, you know, the soft drinks, beer, champagne, Coca-Cola. What they do, they seal under high pressure. No, what for? If they seal under high pressure, what happens? Solubility of the gas will be more. So it is applicable, one application in where? Carbonated drinks. It is applicable in carbonated. What is meant by carbonated? Carbonated drinks. That is in beverages. This application is applicable. Understood, student? That means carbon dioxide will be sealed under high pressure. So application is what? CO2 is sealed under high pressure. Understood? This is one application we say. Carbonated drinks, we apply what? Henry law. Clear for all? So in exam they ask you in which, what are the applications they are. Second application, see, the person who dive in deep sea, you know those persons we call scuba divers. Scuba divers means what? Professional divers. So scuba divers, what they do, when they go into deep sea, they carry a diluted air. Means they don't carry direct air. As you know, air is having what? Nitrogen and oxygen, no? So what they do, they make diluted. So the scuba divers, what they do, see, they carry diluted air instead of carrying what? Ordinary air. They carry what? Diluted air. So diluted air contains how much percent, they ask in exam? 11.7% helium. So in this diluted air, you have to know the composition. In exam, they ask you what is the composition of diluted air. So 11.7% of helium will be there, and 32.1% oxygen will be there, and nearly nitrogen comes 56.4 nearly to this. So this composition you have to remember. This type of diluted air, what they do, scuba divers will carry when they dive in deep sea. What is the reason? So if they carry ordinary air instead of carrying diluted air, if they carry what, ordinary air contains what and what gases, students? Nitrogen and oxygen, they have no ordinary air, and you know percentage of oxygen will be in atmosphere 28%, nitrogen will be 78%. So if they carry, what is the are you getting my point? Why do they carry ordinary air? Why they don't carry ordinary air? Instead of that, why they are carrying diluted air? The reason is, suppose if they carry ordinary air, they go to deep sea, no? So what happens when they go to deep sea? Pressure will be high. Is it right? When pressure is high, what happens? This nitrogen will dissolve in blood. When they are carrying ordinary air, what happens? The nitrogen will dissolve in blood, and when the person come to seashore, so after some time he will come to seashore, no? What happens to pressure when they come to seashore? Pressure will be low. Now what happens? The nitrogen that is present under high pressure, when it comes to low pressure, it will block the blood capillaries. So what this nitrogen does, it will block the blood capillaries, and the person gets severe pain, and that disease is called Bend's disease. So if they carry ordinary air, what is the Bend's disease they get? That means severe pains they get. And in exam they ask you why they can't carry ordinary air. The reason is, if they carry ordinary air, nitrogen will dissolve in blood and it block the capillaries, and the person gets severe pains, and the disease is called Bend's disease. So this make a note. If they carry ordinary air, it causes Bend's disease, BENDS. So that's the reason they carry what, or diluted air they carry, and this percentage you have to keep it in star mark. In exam, what is the percentage may be asked as a memory based question. So remember 11.7%, 32.1% oxygen, 56 rest of the percent comes to be nitrogen. This is the application 2. Clear? Copied everyone? Are you following, student? This is application 2. Now the last application, see, third application. You know, when we go to higher altitude, means at higher altitude, what happens to atmospheric pressure? When we go to mountaineers they carry higher, they go to higher, no, higher altitude. What happens at higher altitude? Atmospheric pressure will be low or not? Are you getting my point? When we go to higher altitude, atmospheric pressure will be less, no? So when atmospheric pressure is less, what happens? The content of oxygen the person may not get much. Do you agree? So oxygen content, if the person is not getting much, might be you study in biology also. What happens? The tissues will won't receive the oxygen easily, and he will get anoxia. So anoxia means something like sleeplessness, I think so. So the person will, due to when they go to higher altitude, at higher altitude, what happens? Atmospheric pressure will be less. So when atmospheric pressure is less, what happens? Intake of oxygen content will be less, and the person will feel what? Anoxia. So here make a note, at higher altitude. At higher altitude, atmospheric pressure, altitude, spelling C, altitude, ALTITUDE, altitude. What happens to atmospheric pressure? Atmospheric pressure will be low, no? When atmospheric pressure is low, what happens? The person gets anoxia. Means what? Insufficiency of oxygen, the person may not, his brain will not work properly, and that disease is called anoxia. So these are the three applications from Henry's law. In exam point of view, they ask, in this most important is diluted air, you put star mark. The percentage they can ask, and these are the applications of Henry's law. Copied all of you? Clear for all? Simple, no? Are you following, students, everyone? So simple chemistry, and I told you on the day what we teach, immediately you have to work on that, because then you will know how far we are teaching here. So on the day today, I thought, suppose Henry's law. On the Henry law, you have to work out from material, content you have to read, and questions related to that. On the questions you have to work from study package from PW. So, and when you get doubts, that you have to clarify it later stage when you have exams. So don't keep pending. So day by day work out so that it makes won't be burden. You may think, sir, what is their exam is so many days, no, why to touch if you think, then bundles will get later, you will be suffered. So continue on the day itself what we are teaching, complete it so that it makes easy. Okay, students, understood? So copy this. And everyone should buy one NCRT textbook. Along with NCRT, you have to have PW study material. Complete. Shall I move to next? Next our discussion will be limitations of Henry's law. There are some limitations are there. So see what are the limitations. Observe here all of you carefully. Limitations of Henry's law. Now, what is this limitation? See, in this limitation, see, the gas should not react with the solvent. So, what is the limitation? Gases should not combine with what solvent? Chemically, it should not react. If they are reacting, it is not applicable. So, in exam, they give you for which of the following gases Henry's law is not applicable. So, make a note, it is not applicable for gases that react with solvent. Are you getting my point? It is not applicable. Henry law, it is not means what? Henry law is not applicable for whom, student? For the gases which react with solvent. For the gases which react with solvent. Getting idea all of it? React with solvent. So gases should not react with the solvent. Then that Henry law is applicable. And second condition, the gases should not undergo neither association nor dissociation. They should not undergo association means what? Combination, or it should not dissociate. So second application is what? Gases should not undergo neither what? Association means union. Association, they should combine. Association is nothing but combination, or they should not undergo dissociation, nor what? Dissociation. And that condition only what this Henry's law is applicable. At this condition only Henry law is applicable. Understood? Gases should not undergo neither association nor dissociation. And the third condition is pressure should not be very high and temperature should not be very low. So what is the third condition? Pressure should not be very high. It should be moderate but not very high. Pressure should not be very high. And temperature should not be very low. So these are the three what we say limitations of Henry's law. So in exam point of view, they may ask you for what are the various limitations by Henry's law. So first limitation is gases should not react with the solvent, that is water. And second application, the gases neither undergo association nor dissociation. And third limitation is pressure should not be very high and temperature should not be very low. So copy these. These are the three important applications from Henry's law. Clear, students, all of you? So this is what, with this solubility of solid in liquid we did, solubility of gas in liquid we did. Now I will share the PPT. Later we do one numerical related on Henry's law. Okay, students? I will share the PPT. Observe the PPT. See till now what we studied: effect of temperature on solubility of gas in liquid. Yesterday we discussed, if you recollect, once you open the notes, dissolution of gas in solvent is exothermic or endothermic? Do you recollect, students, those who are revising yesterday? Yesterday we discussed this dissolution of gas in water is gaseous solution, no? And we get gaseous solution, and this is exothermic reaction. What is meant by exothermic? First year thermodynamics you people studied. Heat is evolved. So exothermic reaction favor low temperature and endothermic reaction favor high temperature. So as temperature increases, what happens to solubility of gas? Solubility of gas decreases. That's what when we go to vendor, what we ask him, give me chilled bottle, we say. Why? When chilled bottle is there, solubility of gas will be more, and we get more kick in that in drinking that drink. Getting idea? So with increase in temperature, solubility of the gas decreases. This is what yesterday we learned. Clear for all? This I am sharing the PPT. See the next one. See this one, dissolution of sugar. Now see, this is the graph effect of pressure on Henry law. That's now we drawn the graph. See. So what is that? He's saying the partial pressure of the gas in vapor phase is proportional to mole fraction. That is what the relation P is proportional to chi we wrote. Correct? And removing this proportionality, we wrote KH. What is KH? KH is called Henry law constant. This is what the relation is showing here in the and graph. When we plot, see, it is passing through origin because it is in the form of straight line. We discussed y is equal to mx plus c form. So where intercept is 0, so it is passing through origin. And what is the slope in this? If they ask the slope comes, so what will be the slope? M is the slope, no? So slope will be KH. Are you getting the point? See, the same thing he has mentioned. Partial pressure of the gas in vapor phase is proportional to, this is partial pressure, is proportional to mole fraction of the gas in solution, and mathematically this is the expression we wrote. Clear? Everyone clear? No? Followed? No? Now see, next see another PPT. See, now tell me, higher is the KH, lower is the solubility. As KH increases, solubility what happens? Decreases. That means KH is inversely proportional to what we can correlate, inversely proportional to solubility. The same point in the PPT is showing. So higher is the KH, lower is the solubility. Clear, student? This already we discussed. And see in the next point. Its value depends on nature of gas. Its value means what? KH value depends. Like just like you remember 11th class KSP. KSP we learnt in 11th. What is that? Solubility product. Like that, every gas will have its own characteristic KH. That means this KH value depends on nature of the gas. It may be carbon dioxide, nitrogen, helium. So this KH value depends on what he's saying, nature of the gas, he says. It depends from gas to gas, the KH value will vary. And see, more is the temperature, more will be the KH. That's what we studied, effect of temperature, no? Are you getting my point? See, effect of temperature in NCERT, what we discussed. As temperature increases, what happens to KH value? KH value increases. As KH value increases, how it is related with solubility? Solubility of the substance decreases. Solubility of gas in water decreases. Same point here in PPT. More the temperature, more will be the KH. That means as temperature increases, KH value increases, he says. Clear all of it? Now see next, see. Henry law is applicable at what condition? That's what limitation we wrote just now. See. At moderate temperature, not at very low temperature, and pressure at a moderate pressure. Not very high pressure, not very low temperature, moderate it should be. That is limitation of a Henry law. Clear? Yes. Now see, only the less soluble gases obey Henry law. See, saw the point? That means the gases should not react with solvent. Suppose if I am taking carbon dioxide, you know carbon dioxide when we dissolve in water it forms carbonic acid. What is the formula of carbonic acid? You study later in organic chemistry. This is reacting gases. So solubility of the gas should be less. For that only Henry law is applicable. The same point in the PPT. Only less soluble gases will obey Henry's law, says. Now the gases reacting with the solvent. See the gases which react with water, for that obeys Henry law is not applicable. Clear? In the PPT, the same point what we discussed here. Gases that are reacting with solvent do not obey Henry law. Clear all of it, right? Now see next PPT. The gases obeying Henry law. See, the gases which are obeying Henry law should not associate. They should not associate, nor they should not dissociate while dissolving in where water. When you are dissolving in water, initially how it is, the substance should be as such. It should not undergo neither association nor dissociation. If it is going association and dissociation, then Henry law is not applicable. Clear for all? So that's what we took in, we wrote in limitation we wrote. Now see next PPT. Now give answer for it. If we increase the temperature, then what will be the effect of solubility of gas in liquid? This has been given in NCERT. So check answer what you give answer for it. With increase in temperature, what will be the effect of solubility of gas in liquid? Recollect. So dissolution of solid gas in solvent is exothermic or endothermic, student? When you are dissolving in water gaseous solution, just now we discussed, no, it is what enthalpy of solution is exo or endo? It is exothermic, no. So as it is exothermic, with increase in temperature, solubility of the gas decreases. That's what in NCERT, aquatic life will be more comfortable in what? Cold temperature than in warm temperature. So here what will be your answer? So with increase in temperature, what will be the effect? As temperature increases, the solubility of the gas decreases. Since the process is what? Exothermic. You have to support why it is decreasing in assertion reasoning, or they give in the form of statement 1, statement 2. Understood all of you? This is PPT and the next see. The next question, tell me what should be the answer. If temperature is increased, then what will be the effect of Henry constant? So as temperature increases, what we learn? KH value will increases. So as temperature increases, what happens to KH value? KH value increases. This also we discussed. And tell me, if the value of KH increases, then what will be the effect of solubility? So KH is inversely proportional to solubility, no, students? So as KH value increases, what happens to solubility? Solubility of the gas decreases. That's what we framed a question, KH values by giving A, B, C, D. I ask you arrange in increasing order of solubility. Getting idea all of you? So higher is the KH, lesser is the solubility. Now see what is anoxia. We discussed this in what applications of Henry's law, that insufficiency of oxygen. Insufficiency of oxygen. So what happens? The person brain will won't work properly due to insufficiency of oxygen, and that disease we are calling as what? Anoxia. This has been given in the NCERT in the form of PPT. Important they have mentioned PW. Now see next. See this question. Why soft drinks or soda water are sealed under high pressure? So same thing, application of Henry law. So mass of the gas is directly proportional to pressure. When they seal under high pressure, what happens? More gas can be soluble. So more gas can be soluble. That's the reason what they do. They will seal under high pressure. Understood? This is what why soft drinks or cold drinks or soda water is sealed under high pressure. They are saying. Clear all of you? Now see what is the unit of Henry law constant? What unit KH will have? So I told you units of KH will be the units of pressure. You remember units of pressure in first year you studied states of matter. Pressure has the unit. What is the SI unit of pressure? Pascal. Or it may have what? Bar. Or it may have what? Atmosphere. These units will be same as pressure unit. So KH will have the units of what is saying. KH will have the units of bar, pressure, etc. Understood all of you, right? Now see last one. See this question. Copy this question. We will work out this question. Now, important in exam, they are asking numericals on Henry's law. Practice more on Henry's law. See, write the problem in your notebook. Data you make a note. What he's saying, nitrogen gas is bubbled. He's saying nitrogen gas is bubbled through water at what temperature? 293 Kelvin. When nitrogen gas is bubbled through water at 293 Kelvin room temperature, he wants see the question. What is asking? How many millimoles? See, millimoles. See, be careful. Millimoles of nitrogen would dissolve in 1 liter of water, assuming nitrogen exerts partial pressure. What is the partial pressure of nitrogen given to you? 0.987 bar given. See, the partial pressure is in the unit of bar, and KH, given that Henry law constant, that is KH. As I told you, every gas will have its own characteristic KH. The KH value given you in the terms of kilobar. So be careful with the unit. See, pressure is present, pressure is given in what unit? If you observe carefully, this is given in bar. So this, whereas KH is given in kilobar. Just like in thermodynamics, as you have to be careful with units. See, one is given in bar, the other is given in kilobar. Then 1 kilo is how much, student? 1000, no? So simple. Now write the data. What he wants to find? Number of millimoles of nitrogen dissolved is asking. How many millimoles of nitrogen is dissolved in 1 liter of water? Volume of solvent is how much here? 1 liter. 1 liter means how many cc, student? 1000 cc, no? 1000 cubic centimeter. And what is the partial pressure of nitrogen given? Partial pressure of nitrogen is exerting 0.987. This much bar he has given. This is the bar unit of pressure given, and Henry law constant given, that is kH. As I told you, every gas will have its own characteristic kH, just like KSP, and this value, be careful here, this is 76.48 K bar given. K means what? Kilobar. So I am converting into 10 power 3. That is bar I am bringing. Okay, because both the units should be in the same option, same unit. No, this is in bar, this is also in bar. Now think how, what is the relation we take? So we write no one relation, partial pressure of nitrogen is equal to Henry constant into mole fraction of nitrogen. This is what the relation we wrote. Now substitute this partial pressure is given how much? 0.987. This pressure is given 0.987 and KH value is given 76.48 into 10 power 3 into mole fraction of nitrogen we have to find. So now in this is unknown. No, now bring mole fraction of nitrogen. Mole fraction of nitrogen comes 0.987 upon what? 76.48 into 10 power 3. Now this we have to simplify it. On simplifying this 10 power 3 I am bringing numerator. This makes 10 power minus 3. Now 2 multiple you cancel, 2 3s are 6, 2 8s are 16, 2 2s are, 2 4s are, 2 4s are 8, 2 9s are 8, 2 9s are 18, 2 3s are 6. So I make it as for simplicity 0.493 by I am put the decimal after one digit. See student, for my convenience sake roughly I am taking into 10 power minus 3. See I made the decimal to move on right side by one digit. That means here what do I get? A 10, no? Because understood, I move the decimal here and I am making roughly as a 4 for easy calculation. So this 10 when I bring numerator that makes minus 1. This exponent comes 10 power minus 4. Roughly I am taking here if it is 4. So this will cancel, 4 1s are and 4 2s are 8. 1 will be the 0.126. Now roughly I am getting mole fraction of nitrogen is to be 0.126 into 10 power minus 4. Check everyone got same or not. You have to be calculate. You have to do calculation part. So find, I got the value of mole fraction of nitrogen 0.126 into 10 power minus 4. But this is not our answer. What he wants, see the question carefully. Number of moles of nitrogen he wants. Up to this, copy this. Clear all of you? So next what we have to find? We have to find how many moles. So how we get moles? We learnt in previous class mole fraction of the nitrogen is equal to, how we get mole fraction of nitrogen? Do you remember? Number of moles of nitrogen by number of moles of nitrogen plus number of moles of water. So the value what we got, this mole fraction, you correlate here. Now I am writing here, see the value of mole fraction, how much I got? 0.126 into 10 power minus 4, and moles of nitrogen I have to find, that is unknown, and this moles of nitrogen in the denominator is negligible. Why? Because very less amount of nitrogen is present, no, so I have to consider only moles of water. So to get moles of water he has given weight of solvent. How much he has given? 1000 cc, means density of water is how much? 1 gram per cc. So can I take this as 1000 grams? So this I have to take, understood why I am taking 1000 by 18. Why I am taking 18 molar mass? So mass by molar mass will give moles. Understood? 1000 upon 18. Are you following all of you? This is what, now I have to find number of moles of nitrogen. Now see, number of moles of nitrogen is equal to this 0.126, what we got mole fraction, into 10 power minus 4. That I have to multiply. This 1000 by 18 comes how much, students? 55.5 we get. Check. Is it right? 18,000 upon 18, that comes 500 by 9, students. That will be simplification, you get 55.5. Now multiply 55.5 with 126, put decimal after 4 digits. So 126 into 10 up to this copy it, and this value we get in moles we get. Are you getting idea? This answer we are getting in moles, but question is asking in what terms? Millimoles. You have to convert the millimoles into millimoles. Copy this up to here. Understood all of you? So this is what the relation we took, and we are finding how many moles present in millimoles we have to find. Up to this copy, then I will continue in the next page because page is not there. Copy this all of you. So more numericals we get from solution chapter. We in second year we are having solutions, electrochemical kinetics. These three chapters are weighted chapters in JEE as well as in NEET. And in our PW also they mentioned in the beginning, if you have taken the study material, in the beginning of the chapter they will mention on what topic you get more weightage. You can see the percentage wise they given 7 years JEE means papers they have taken. In that weightage wise they have given. Based on that you plan it, means on what we have to focus more, which concepts we have to focus more. All that analysis have been given clearly by PW. So one should be smart study. That means what we have to study, where we have to get marks. In that way you have to study. Planned way you have to revise all the concepts, where the concepts you have to study and which they are asking more number of questions, how to crack JEE mains. In that way, planned way you have to study. But don't keep burden. That means everything you should not concentrate. Most important what they mentioned that you focus more. But you study all the thing, but focus more on what? More important topic. Copied them up here. This is what moles of nitrogen we got. Check everyone got this moles of nitrogen. Multiply that 126 with 55.5. Up to this copied all of you. Or everyone following them and be regular for the classes. I told you from day one onwards. If regularity is not there, then continuity is not there, you won't understand. So my humble suggestion is be regular for the classes from day one onwards. If you are regular for this 1 year, surely you will get good rank. But along with that, you have to interact with the teacher and you have to solve daily 20 to 25 questions. Copy now. See next time going into the next page, as space is not there. What? How many moles we got? See 0.126. 0.126 into 10 power minus 4 into 55.5. These many what we got, moles we got. But question is asking millimoles. Now multiply 126 with 55. 555 approx you take. 5 6 are 30, 2 5 are 10, 13, 1 5 are 5, 6, 5 6 30, 2 5 10, 13, 1 5 5 6, 5 6 are 30, 5 6 30, 5 2 are 10, 13, 1 5 are 5, 6, 0 3 9 9 6. We after how many digits place decimal? 4 digits we place decimal. That means it is coming 6.993 into 10 power minus 4. These many what we are getting, moles we are getting. Check everyone. Do you got the same? This is what we got in moles. But option is asking in millimole. And you know in first year, 1 millimole is how many moles, students? 1 millimole is 10 power minus 3 moles. No, milli prefixes. So for 6.993 into 10 power minus 4 moles, how many millimoles it will be? So this what you do, 6.993 into 10 power minus 4, you divide with 10 power minus 3. Minus 3 when I bring numerator, that comes 10 power minus 1. That means after one digit when I place decimal, see you will get 0.6993 These many millimoles we get. Check everyone got the same answer or not. Approximately 0.6993. These many millimoles of what is present? Nitrogen is present in 1 liter of water. So here, student, you have to be careful with units. See, one is given in kilo Pascal, the other is given in Pascal. Just like in thermodynamics, no. In thermodynamics also you have to be careful with units in first year. So this is what Henry's law. So we conclude here as time is over. Tomorrow we continue with vapor prayer. Vapor prayer of solid in liquid. Vapor prayer of solid liquid in liquid. Our discussion will go tomorrow. So today what you do, recap once again in the class what I taught till Henry's law, starting from introduction to Henry's law. Okay, students, bye. I'm ending the session. Wish you all the best. Right.